Okay. So 22 on the homework, it looks like this. I'm writing on the Moby board the whole time because it's your guys'
we had it
turn.
yesterday.
No. Well, yeah, but I wasn't recording. I was just teaching on it. Okay. But today I got to record, so I'm doing this. Y equals or x equals that, and y equals that, and y equals 1 minus t. But they tell you to eliminate the parameter. Basically, that means get rid of t, right? Hello.
Yeah.
Right. So you can solve this. T equals 1 plus y, isn't it? T equals 1 minus y. That would work, right?
Yeah.
1 minus y. Then you take that and you put it in here, right? And so you get x equals the absolute value of 1 minus y, right? Did I do that right? 1 minus, oh, is that wrong? Did I write it down wrong?
So if it was y equals t plus 2.
Oh, I wrote down the wrong problem. I kind of mixed the problem, okay? So y equals t plus 2, sorry. Y equals t plus 2. So you solve for t and you get t equals y minus 2, and then you plug that in, and then you get the absolute value of y minus 3 is equal to x. So you're almost done, but you want to solve that for y. Do you guys know when you solve an absolute value equation, you have to do a minus part and a plus part? Y minus 3 equals negative x, or y minus 3 equals positive x. Did you know that? Okay. And now you have y equals 3 minus x, or y equals 3 plus x. And those are your two equations. But they also ask you to put domain restrictions on the equation. What has to be true about x up here? What is x always going to be? X has got to be greater than 0, right? So x has got to be greater than or equal to 0. So over here, you have to say x has got to be greater than or equal to 0, because if I can plug in any value of t, right? But x is always going to be positive, right? So x would have to be greater than or equal to 0. Yeah?
Yeah.
More questions? Oh, you asked me about 38. You can't do 42 until you do 38.
All right.
What? Someone keeps texting me or email. What?
It's me.
Can you do it the other way? What do you mean?
Never mind. I was going to say
Oh,
like solve for.
Solve for x first and then plug in t. I think so. Yeah.
That's what I did.
Yeah.
I got the same answer.
You got the same answer. Yeah. Okay. 38 is kind of weird because they give you to know how to do this without some help would probably be hard. X equals, because the first time I looked at this, it was like, what are they talking about? R cosine theta, and y equals k plus r sine theta. And this kind of looks like something that looks kind of familiar. So the trick here is x minus h equals r cosine. So the parameter, they say eliminate the parameter. In this case, the parameter is theta. So it's just as if I had instead of calling this, could everyone please, come on. I get angry with you guys.
I did it a different way, and then I looked at Calc Chat, and then
Oh, you looked at Calc Chat. Okay, so this gives you x minus h squared, right? Equals r squared cosine squared. But what you do with this is you add together the two equations. So I'm going to add the left side of both equations together, which gives me x minus h squared plus y minus k squared. I have to shut that phone off. Equals r squared, not yet, r squared cosine squared theta plus r squared sine squared theta and then you can factor out an r squared out of here. And what's cosine squared plus sine squared equal to?
1.
That's it, equals 1. So this quantity here is equal to 1. So what you end up getting is r squared is equal to x minus h squared plus y minus k squared.
So the only reason
So, gosh, something is,
the only reason you squared it was to get it in the standard form like that?
yes. I gotta shut my phone off or something.
They're still recording.
Now it won't shoot up. Stop ignoring me.
Possibly.
What's your number?
So your video's still recording.
Okay. I'm still recording. That's okay. Okay. So this is the equation of a circle, right? Right?
Yeah.
Good. So what that tells you is h and k, right? Those are, so if you put this x equals h plus r cosine theta and y equals k plus r sine theta, that pair of parametric equations will give you the equation of a circle with center at hk and radius what?
Squared.
Radius squared? What?
That's what the equation.
What's the rate and radius r, okay? So if I want to graph a circle with the center at, say, 2, 5 and a radius of 6, I could go x 2 plus 6 cosine theta, and y equals 5 plus 6 sine theta, good? Then that gives me the equation of a circle with the center at 2, 5 and a radius of 6. Good? That's all that is.
Okay.
All right.
Then 42
So then 42 would be easy, right? Okay?
Oh, yeah, wait.
I did that, but when I graphed it, I got like sine and cosine equations. So I have to like.
Okay, yeah, that makes
Yeah.
sense.
Yes, sir.
We do 49.
No, I'm not going to do every problem on your own. Okay? I already did it the 10 minutes you weren't here. All right? So, do you have, and do you want me to talk about that, the baseball problem? Number
Yeah.
61,
Yeah.
okay? I just want to kind of show you on the graphing calculator what I did, okay? So with 61, okay, I plugged into my calculator. So you have these two equations. One deals with the angular, or the horizontal component of the velocity, and this one deals with the vertical component of the velocity. And this 146.7, this should have been 146.7. This, because they tell you that the initial velocity is 100 miles an hour, but that can be converted into feet per second as about 147 feet per second. Cosine of 15 times t. This is the initial height of the object, 3 plus 147, which is the initial velocity, sine of 15. So 15 is like the angle that so there's a baseball player, right? He starts at 3 feet and he's trying to hit a home run, right? And he needs to get that ball to go 408 feet, I think it is, and go over a fence that's 7 feet high, yes? So this point right here needs to be at least 408,7. You understand that? Okay. And so if you put this into your calculator and you set up the window and everything, So this one is making it go up and down, this one's making it go across. And if you hit graph, I'm just going to change this to 147 so that it will graph again. Otherwise, it'll just show me the graph. So you could see, here's my baseball player. He hits it, going. Is it gone? No, it's not gone, because if I hit trace, okay, and this only goes to, whoops, if I hit trace, this doesn't go all the way to, it stops at like 350 feet. And then it asks you to play with the angle and see if you put in 23 degrees, does he hit a home run? And yes, if you put in 20, see, like right here, he's hit the ball 313 feet. That's how far it goes horizontally.
How far does he need to hit it?
It needs to be 408, right? But so the baseball is 7.2 feet above the ground right now. So right now, it's not going to clear the fence anymore. See that? Okay, because it's, and so at that point, no, he's not going to hit a home run. Then they ask you to go back in and change this angle to 23 and see what happens, right? So 23, I'm not going to do it. But if you put in 23, he does clear the fence. And then it asks you to find the maximum angle, or the best angle to get the most distance. And that angle, you just have to play with putting in different numbers, and it comes out to be about 19 degrees. When you take calculus, you'll figure out how to calculate the best angle using the derivative of parametric equations. But you only get derivatives of parametric equations when you you take Calc BC. Can you put your phones away, please? Good, then put it away. If you're not on, you can put it away.
No time.
It's being charged.
So are you. You're going to be charged in a court of law for having your cell phone out. For having your cell phone out in class. All right. Okay, so the next thing is polar coordinates. You ready to learn about polar coordinates?
Yeah, most of them.
Well, most definitely. Indubitably.
Can we have the fact of the
The
day?
fact of the day is, who is the best math teacher ever? If you get it right, you get a Tootsie Pop. No. It is estimated that 1 in 10 babies born in Europe were conceived in a bed purchased from what retailer?
IKEA.
Okay, that was pretty easy. That doesn't matter.
Wow.
No, Hunter knew it. He gets the lollipop.
Yeah,
Okay.
I said it.
Wait. Yeah, but you got one yesterday. All right. So this is 9-4. Am I still recording?
This is 5.
Thank you. 9-5. This is called polar coordinates. Okay? So all polar coordinates, they're another way to get to a point in the coordinate plane. So for instance, if I have some point 1, 2, 3, 1, 2, I'm going to make sure I'm recording. Okay? I'm recording. Okay? If I have some point 3, 2, I can get there by going over 3 and over up 2. That's the only way I could get there. Yes, sir.
How many more chapters do we have after 9?
After 9, 10, and 11.
We,
So we only have 2 more tests after this.
Yeah. Yeah, and 10 is short. We just do some stuff. And 11, we just do 4 sections.
yes.
Yes, for me. Right? So if this is a point 3, 2, another way that I could get to this point is by going over some amount, okay? By going over some amount and then rotating through some angle, okay? And that's what a polar coordinate is, okay? It says I go out some amount and I rotate through some angle. So when you get polar grid paper, I'm not going to give you any today, okay? But what it looks like is a bunch of circles, okay? And here's a circle that goes through that one. Here's another circle that goes through, like they'll have a circle going through 3, 4, 5, and stuff like that. So you would go over 3, and then you'd rotate through some angle theta. Okay, so polar coordinates look like r, comma, theta, where r is called the directed distance. Okay, r is called the directed distance. Directed distance. And theta is called the directed angle. Directed angle. And this axis here is called the polar axis instead of the x-axis. Called the polar axis. And so, if I want to get to this point using polar coordinates, we'll talk about specifically how you get there. I could go out some amount and then rotate through. I wouldn't go out 3 because that wouldn't correspond to 3, 2 in the rectangular coordinate system. It would correspond to something bigger or smaller. But we'll talk about that in a minute. But and what else do I have to talk about here? Directed angle, directed, polar axis. This is called the pole. Okay? That's called the pole. And then, unlike an xy coordinate, you could have infinitely many ways to get to this point. Because I could have gone out 2, and then, or out 3, and then I could have rotated around that direction, right? Or I could have gone back 3, and then I could have, or I could have gone out so far and then rotated through that direction. Or I could have gone out that far and rotated through that direction. So polar coordinates are not unique, whereas rectangular coordinates are unique. So if you're in the rectangular coordinate system, there's only one way to get to 3, 2. But with polar coordinates, there's more than one way to get there. You understand that? It's like Google Maps, you know? Anyway, so for example, so plot the point, plot the point 2, comma, pi over 3 in polar form. Okay? So what you do is, I'm just gonna draw where's my, this thing, I'm gonna draw an axis here, axis there. I'm gonna make a circle. I'm not giving you polar grid paper. Maybe I will if you need it at the end of the period. But so if I want to graph the point 2, comma, pi over 3, if I go, so say this is 1 and this is 2, the way I get there is going out 2 and rotating through an angle of pi over 3 radians, right? So this is going to make it green. We'll go like this. We'll do this. So this is the point 2, comma, where this angle theta is equal to pi over 3 radians. You get that? Out 2, rotate through pi over 3. Find 4 other ways to get there. 4 other ways to get there, or that are concurrent with that point. Remember this when we did pre-calc? So another way I could get there is by going out 2, and then what, Greg? Give me
2, 5.
I could do that. So I could go 2, comma, and then I could go around the circle once, and then add that little pi over 3. So that would be 2, comma, how many pi's over 3 would that be? 7 pi over 3. What if I went this way, and then I went this way? How many pi's over 3 would that be? That would be 2, comma, negative, how many pi's over 3? 5 pi over 3. Okay, so another way would be to get, what if I went in the negative direction? What if I said negative 2, So if I went backwards 2, that's negative 2. How far would I have to go to get here? How many pi's over 3 is that?
4 pi.
4 pi, right? I could go back 2 and around 3 pi over 3 and pi over 3 more. So I could go negative 2, 4 pi over 3. Give me one more. Negative 2, what's another way?
7 pi over.
Well, what if I went back 2 and then this way? Back 2 and then that way. What would that be?
Negative 2 pi.
Negative 2 pi over 3. So there's lots of different ways to get there, right? So it's called, so the next, we're Roman, okay? So the next thing is called coordinate conversion. So you can use these to go either direction, okay? So, and all of these are based on the idea that, whoops, I don't want arrows on one end. I want arrows on both ends. Oh, that's not where it's at, okay? So this is based on the idea that if I were to draw in a triangle here, like right here, and then right here, if this is R, and this is Y, and this is X, and this is theta, right? We know that the sine of theta is equal to what over what?
Wait, say that again.
Sine of theta is y over r, right? Which means that y can be written in polar form as r sine theta, right? And cosine theta is x over r, right? And so x in polar form can be written as r cosine theta, right? And we also know by the Pythagorean theorem that x squared plus y squared equals r squared. Or you could also write that as r is equal to the square root, of x squared plus y squared, because you don't have to worry about the negative part of that. And then you also know that tangent of theta is equal to what over what? Y over x, okay? So this stuff right here, wow, watch this. These are things that you should know to convert. Yes, ma'am?
What does that say on the top? Conversions?
Conversions. Conversions. Okay?
So, there's no N at the end. It's not N. It's like I-O-U-S.
Is this an English
How can you not read that?
Hey!
That's awful.
Okay, be quiet. So, quit making fun of Mr. Leader. That's right. You try writing on the Moby board. Okay?
Get off this phone.
Yeah. So convert. So let's do this. Convert. Convert. 4 comma pi over 4, which is in r theta form or polar form, to rectangular. To rectangular, which means xy form. And all you have to do in that case is, this is r, okay? Here's r, and here's theta, and you just plug into these formulas, right? So x equals 4 cosine times pi over 4, and y is equal to 4 times the sine of pi over 4. Does anyone remember from first semester what is root of 2 over 2? So that's 4 times root of 2 over 2, which is equal to 2 root of 2. Oh, the math here. 2 root of 2. And this is also equal to 2 root of 2, right?
I thought it was 4
What?
Sing us your song.
4 times root of 2 over 2, which comes out to be 2 root of 2, okay? 2 root of 2, okay? And so what that means is that if I were graphing the points, okay, that where, let me just draw a circle real quick. if I had a point where I go out, 1, 2, 3, 4, and rotate through an angle of pi over 4, which is how many degrees? How many degrees is pi over 4? 45 degrees, okay? That would be the same as if I went over 2 root of 2 and then up, whoops, that's not very good, and then up 2 root of 2. You understand that? Okay? So to get there, I could either go out 4 and rotate through that angle, or I could go over 2 root of 2, which is about 2.8, and up 2.8. See? Yeah? Isn't that cool? Okay. So now we're going to go the opposite direction. Okay? Okay? You thought we're just going to go in one direction, but we're going to go in the opposite direction. So now we're going to convert. That was a bad
That was
joke.
good. I like that one.
Thank you, Sean McKinney. All right. So convert 3 comma negative root of 3 to polar form. Okay? So the first thing you could do is get, let's get theta first. Okay? So we know that the tangent of theta is equal to y over x, right? So, so tangent of theta is equal to 3 negative root of 3 over 3, right? Where is tangent equal to negative root of 3 over 3 on your unit circle? Do you guys anyone remember?
Goes pi over 6. 2 pi over 6. What?
Is it 5 pi over 6 or 4 pi over 6? Negative 4 pi over 6.
Down here.
Oh, yeah.
It's down here. So you could call this angle either negative pi over 6, or you could call this angle from here to here 11 pi over 6. Doesn't matter. It will get you to the same spot. Okay? So theta is equal to either 11 pi over 6 or negative pi over 6. Let's call it negative pi over 6 for right now. Okay? How do I find r? How do I find r?
You make a triangle.
R is equal to the square root of x squared plus y squared, okay? Which is equal to 3 squared plus negative root of 3 squared, okay? The square root of that, which is equal to the square root of 12, which is equal to 2 root of 3. So to write this in this same coordinate in our theta form, it would be r is 2 root 3, and theta is either 11 pi over 6 or negative pi over 6. Okay? But you have to be careful, because if these two things were switched around, okay, say I had negative 3 here and positive root of 3 here. What's the, what quadrant is this in? What quadrant is this in?
2.
This is in quadrant 2, right? But if I tried to take the inverse tangent, if I took the inverse tangent to find out what that angle is, root of 3 over negative 3, I'm going to get out negative pi over 6, right? So just like you did when we did trig, you have to pay attention, because inverse tangent can only give you one answer. And it gives you that answer down here. So I need to add 180 to it, okay? So if this were the case, this angle would be 5 pi over 6, not negative pi over 6. You understand that? So you have to pay attention to which quadrant you're in when you're finding that angle. So this is in the second quadrant. This one is in the fourth quadrant, right? So in this case, negative pi over 6 or 11 pi over 6 is fine. In this case, 5 pi over 6 would be the angle, even though when I took the inverse tangent, I get this as my answer. So tangent of theta is equal to this. That does not mean that inverse tangent of this is equal to theta. Yeah? It'll give you the negative. Okay, are we done yet?
Yes.
Guess what, we're not done yet. Okay, because we have more conversions. Lollipop. 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 We are the lollipop. Oh, that's from the. I know that. That's from the Wizard of Oz. Wait. You know the Wizard of Oz? Okay. Y equals x squared. Okay. So convert to. So sometimes you'll have to convert entire equations to polar form. So. So this looks like a parabola, right? If I graphed it, why would you want to convert this into polar form? Probably you wouldn't, but just in case you did, okay? The way you do it, you know that y is equal to what? What's y equal to? R sine theta, right? And x is equal to r cosine theta, right? And so now it's converted, right? But you probably want to simplify that a little bit. And so this is r sine theta equals r squared cos squared theta. What can I cancel out from those two things? An r, right? So you could get rid of an r, tally, we're talking, okay? And I get r. And usually when you're finding a polar equation, it's r equals. Just like for a linear equation, it's y equals, or a parabola or something is y. So here you want to solve for r. So I get r is equal to sine theta over cosine squared theta. You could leave it like that, or if you're really ambitious, you can change that into tangent theta. And you remember trig from last semester? What's 1 over cosine theta equal to? Anyone remember? Secant, okay? So you could write this either as this or like this would be. No, because tangent is sine over cosine, right? So I already got rid of one of those cosines by rewriting this as that. Okay. Then one more thing, or two more things. R equals 2. Convert to rectangular xy form. Rectangular. What's r equal to? What's r squared equal to? R squared equals x squared plus y squared. So if I know that r is equal to 2, what's 2 squared? 2 squared is equal to x squared plus y squared. Or 4 equals x squared plus y squared. What's this the equation of? Circle. That's the equation of a circle in rectangular form. This is the equation of a circle in polar form, okay? Because this is saying what is the equation, what shape does it make if r is always equal to 2? What shape does it make? Circle. It makes a circle with a radius of 2, right? So this radius is going to be 2, right? And it doesn't matter what the angle is, it's all the points whose radius is 2 would make a circle, right? And to convert it, you can square this squared, and we know that r equals square root of x plus y, or r squared equals a, and that's how you do it. Last thing, okay? Promise. Convert, that's a weird T. Theta equals root of 3 over 3. Is that what I have? Root of 3? No, that's wrong. You can't have a root of 3 over 3 as a theta. Theta is equal to pi over 3, okay, to rectangular. And this one, I remember I had one like this on test. Everyone goes, oh, I don't know how to do that because I was on my cell phone while you were teaching it. Okay, that's not what they say, but that's why they don't remember it, okay? So, so anyway, if I had one like this and I were graphing this, right, what do all the points who have an, if I'm in polar form, what are all the points whose theta is equal to pi over 3 look like? What does that look like? If theta is always pi over 3, and r can be anything, what shape is it?
Circle.
Uh-uh.
Triangle.
It would be a line, right, which makes an angle, right? It would be a line that makes an angle of pi over 3 with the polar axis, right? And since r could be negative or positive, it could go either this way or this way. So that really makes a line, right? So that's this right here where this angle is pi over 3, right? R could be negative or positive, so it could be every single one of these points. Yes, ma'am?
If it's pi over 3, wouldn't it just be the fourth quadrant?
No, because r, so remember it's r theta, right? So r, it's like with y equals 6, makes a horizontal line. X could be anything, right?
No, but I mean like for pi over 3, since it's that one in the first quadrant, but then negative pi over 3 is in quadrant 4, right?
Right, so it's not negative pi over 3, that would be going this way, right? But pi over 3 goes this way, but r can either be a positive number or r can be a negative number. So if I said r was a negative number, right?
I gotcha.
And then I rotate it through pi over 3, that would put me on that line as well, right? So then what I have to think of are what is the invert, or what is the, so if tangent of theta, right, is equal to y over x, right? So then tangent of pi over 3 is equal to y over x. What is the tangent of pi over 3 in terms of, like, exactly? Does anyone remember tangent of pi over 3?
Square root of 3.
It's just square root of 3, not square root of 3. So this says that root of 3 is equal to y over x, which means that y is equal to x, or the root of 3 times x, which is a line with a slope of over 1 up square root of 3, right? Slope, and goes through the 0, 0, right? This would be a linear equation with a slope of root of 3 over 1 and a y-intercept of 0. So that's how you would do something like that in rectangular form. Okay? Okay. That's all she wrote. All right. So now I'm going to stop. I talked